Welcome back. Today we are going to be doing two different questions involving annuities as well and future value. The only difference is this time, instead of looking at how much we're going to be setting aside each month and figuring out, okay, well, how much am I going to have in 10 years from now, in 20 years from now, etc. In this case, we're going to have a specific goal in mind of I want to have a certain amount of money in a certain number of years from now. How much do I need to set aside right now in order to make that happen? And that way we can see, is that a realistic thing for us to do and how can we get there potentially? So let's start with this first example. Robert wants to have $5 million saved for retirement 25 years from now. How much each month does he need to invest with a 10% annual return compounded monthly in order to reach his retirement goal? Okay, so what we're going to do is first we're just going to write down what's given. So future value would be $5 million because that is how much money Robert would like to have for 25 years from now. So that's our ideal future value for him to have 25 years from today. Then we have I, which is our interest rate. Now that interest rate is going to be equal to 10%, so zero point 0.1 over 12, because keep in mind that's an annual interest rate, and this is being compounded monthly. And also, too, they would like to know how much each month. So, how much monthly does he need to invest into this plan in order to end up with that $5 million that he would like to have, right? So, this is going to be 0.0083 repeating like that. Okay, next we have n, which is the number of compounding periods. So what would that be? Well, he's going to be doing this for 25 years, and every year there are 12 months, so there's 12 compounding periods, given that this is compounded monthly. So that number can be found by multiplying 25 by 12, and that is 300. So this is going to compound 300 different times. All right, so next what we're going to do is we're going to plug in all of these numbers into this equation. So A is equal to 5 million times 0.0083 repeating over 1 plus 0.0083 repeating to the power of 300 minus 1. All right, so some tips for not messing up the calculation step. So first thing I would say is to first type into your calculator 5 million times 0.0083 repeating, hit equals, then hit divided by, and then a bracket, and then a second bracket, 1.0083 repeating, end bracket, and then we want that number to the power of 300, so power 300, and then minus 1, end bracket, and then hit equals. And then that should give you the correct answer. Another way to do it, if you don't like to put it in all at once, you can figure out what the numerator is and then figure out what the denominator is separately. Make sure that you round to a few more decimal places than you need to right up until the final answer, just to avoid rounding error. And then you can, do the division separately. And so if we do that, we're going to end up figuring out that Robert needs to set aside $3,768.37 per month in order to make this happen. Now, that might be very doable for him, right? Depending how much money he makes, we don't really know. But other people might look at this and say, like, that's more than a mortgage payment. That's a lot of money. How is he supposed to do that? Well, let's say that you put in the goal and you realize it's, very out of reach. You have a couple options. You could delay retirement. So maybe he could figure out how much he'd need to start saving for 30 years from now instead of 25 years from now if this is not doable. Another potential is he could lower the amount he wants for retirement. So, would he be okay with, instead of 5 million for retirement, which is quite a good, comfortable retirement, would he be okay with 4 million for retirement? Right? We could lower the bar a little bit because $5 million is quite a lot of money, but you can certainly retire on less than that. By no means do you need $5 million to be able to retire. So we can make that. So that's the beauty of this is, let's say that you figure this number out and it doesn't end up working out for you. Well, then you can adjust some things in order to in order to figure it out. Someone else might argue that a flaw with this problem is, what if we don't get the 10% annual return? Maybe we want to be more conservative and assume that we're only going to get a 6% or 7% or an 8% return. And that's fine too. We could switch that as well in order to, get a more conservative approach here. Of course, that'll mean the amount we have to set aside goes up, but better to underestimate, better to underestimate what our return is going to be than to overestimate it in some senses. All right, let's move on to the second example. Sarah wants to have $75,000 saved for her daughter's education fund. Her daughter will start post secondary 18 years from now, and Sarah expects the investment to be at an annual interest rate of 7% compounded monthly. What is the monthly amount that Sarah must set aside to reach this goal? Okay, so same kind of thing here, except of course $75,000, even though that's still a lot of money, of course, that's way, way less than 5 million. That's a small fraction of that, but there also isn't as much time, right? There's only 18 years before Sarah's daughter will go to school. So let's figure out how much she must save for this goal in order to meet her daughter's education needs. So in this case, the future value, the amount of money that Sarah would like to have saved, is $75,000 for her daughter's education. The interest rate, I, in this case, is going to be 0.07 divided by 12, because the annual interest rate is 7%, and it's compounded monthly, so we have to take that number and divide by 12, and that gives us 0.00583 repeating. And then we have n. What is the number of compounding periods? Well, there's 12 compounding periods every year, since it compounds monthly at each month. And there's 18 years that she plans to make this monthly payment, essentially, to herself for her daughter's future. So 12 times 18 is going to give us 216. So that means there's 216 compounding periods. So now we're going to figure out the monthly amount Sarah must set aside. So A is going to be equal to 75,000 times I, so 0.00583 repeating, divided by 1 plus 0.00583 repeating, to the power of n, so power of 216 minus 1. Okay, so let's talk about how we can not make an error when we're multiplying all this out. So start with $75,000 times 0.00583 repeating, and then hit equals. Okay, then we're going to click divide, and then we want two brackets, and then 1 plus 0.00583 repeating, or you can just put 1.00583 repeating, that's fine too. And then we're going to do n bracket for one of those brackets we started, and then power of 216, and then minus 1. And then we're going to do n bracket, right? The reason we're doing that second set of brackets is to show that we're taking the top, the first number we got, we're dividing it by the entire bottom, right? So that will avoid it just dividing it by this number here and then subtracting 1 from the result of that, right? That's going to get us the wrong answer, definitely. So the answer that I got here is $174.13. So if she does $174.13 per month, starting now, for 216 times, she will end up with this $75,000 goal for her daughter's education fund at this 7% return. And this is good. This is pretty realistic. $174 a month is a lot more realistic for most people than that 3,000 number we saw earlier. And also the 7%, the 7% annual interest rate is a pretty decent estimate as well. I think that's a pretty realistic annual interest rate to calculate with. All right, well, as always, if you have any questions, feel free to leave those in the comment section, and we'll see you for the next one.